Hi everyone, welcome to my channel. My name is Mike. I am a software developer, and I've recently started learning more about system design. Over the past few months, I've been writing blog posts to document what I'm studying. However, I realized that just reading articles and drawing diagrams on paper isn't enough. Many things only become clear when you actually try to implement them. That's why I decided to start this series called Paper to Code, where I take ideas from my own blog posts and turn them into real working code. This is the very first episode. Today, we are going to build a Twitter-style social media system based on one of my recent blog posts. I am still learning a lot, so this project is far from perfect. If you notice any mistakes or have suggestions, please feel free to share them in the comments. I really appreciate your feedback. So what is this blog post about? It's a big picture system design article about building something like Twitter. Lots of diagrams, but no code. It talks about following, posting tweets, and uploading photos. But the main focus is the home feed. The post explains why the feed is so difficult. The system is read heavy, shows some realistic daily numbers, and says it's okay if a new tweet takes a few seconds to reach everyone. It walks through the main pieces: load balancers, app servers, sharded databases, caching, and CDNs. The most interesting part is how to build the feed. There are two approaches: the simple way, query when you open the app, and the fast way, using a queue and workers to pre-build the feed. But the fast way breaks for celebrity accounts with millions of followers. So the post recommends a hybrid solution: pre-build the feed for normal users, but fetch celebrity tweets on the fly and mix them in. In short, it's about handling huge numbers of reads while keeping the feed fast. Now I'll show you the working demo I built based on these ideas and what I learned when I actually ran it. Now let's talk about the actual project. While the core ideas come from the blog, the implementation has some differences from the theoretical design. First, instead of multiple API instances with a complex load balancer, I used a single fast API service behind Nginx. Nginx acts as both a reverse proxy and serves static files and media. For storage, I'm using PostgreSQL for persistent data and Redis for feed caching and real-time pub sub. Posts are processed asynchronously through RabbitMQ, with a Python worker handling the fanout. Media files are stored in Minio, which is S3 compatible. The front end is built with React and TypeScript, using WebSockets for live notifications. The entire system runs with Docker Compose, so you can start everything with just one command. Alright, let's bring this project to life. First, we'll start the entire system using Docker Compose. While the services are starting, you can see we have several containers: the Fast API backend, Redis, PostgreSQL, RabbitMQ, Minio, the worker, and Nginx. Once everything is up, we open the application in the browser. As you can see, this is a demo environment, so there's no real authentication yet. We select a user from a list. But right now, the database is empty. There are no users or posts. To make the demo more interesting, I have prepared a simulation script that creates realistic data. This script will create multiple users, generate follows, and post some content. While it's running, let's take a quick look at the monitoring dashboard I built with Grafana. As the simulation runs, you can see the metrics changing in real time: number of users, posts being created, and system load. Let's wait for the simulation to finish. Great. Now let's go back to the application. First, we select a user. Let's pick the first one. You can see the home feed. Right now it's empty because we just started. Let's follow some users first. Now you can see the posts that were generated by the simulation script earlier. Let's create a new post. I'll write something and attach an image. The post appears immediately in our own feed, thanks to optimistic update. Now, let's switch to another user in a new tab. I will create a post using this user to see how the system handles it. Now, open two windows side by side to see what happens. Right after the post is submitted, the first user also receives a notification about the new post. When we click the Load New Posts button, the post list is updated, with the newly published post appearing at the top. At this point, the newsfeed system is working as designed. Let me explain what's happening behind the scenes when we click Load New Posts. Here's where the hybrid logic comes in. When a new post is created, it's sent to RabbitMQ. Then the worker picks it up and processes it. If the post is from a normal user, the worker pushes that post into the feed cache of all their followers in Redis. If the post is from a celebrity account, we don't push it to millions of users. Instead, we just mark it as a new celebrity post. Then, when a user clicks Load New Posts, the system does the following. First, it fetches the pre-computed feed from Redis for that user. Then, it queries the latest posts from any celebrities that user follows. Finally, it merges those celebrity posts into the cached feed and returns the combined result to the user. This is the hybrid approach, combining the best of both pre-computed and on-demand strategies. That concludes the demo. Overall, I'm quite happy with how this project turned out. The real-time notification, hybrid feed, and Docker setup work smoothly. However, there are still many areas for improvement. Authentication is missing, the simulation script is quite basic, error handling can be better, and the UI is still quite simple. Since this is my first video in the series, there are definitely some mistakes and rough edges. I'll continue to improve both the project and my presentation in future episodes. If you have any feedback or suggestions, please leave them in the comments. I really appreciate every single one of them. Thank you so much for watching. If you found this video helpful, please like, subscribe, and turn on notifications. See you in the next episode.